The next presentation is going to be given by the other team that was the People's Choice winner. And again, the team leader was Ann Wang from Purdue University. And I see several individuals walking toward the stage. So please come and do your presentation.
Hi, so all of us wanted to be on the stage. We are thank you. We're the so-called Team 2 from the iGuide Summer School. And we are Sukanya, Dami, Elaina, and Marija, myself. This is our fearsome leader, Dr. Jean Wang. And unfortunately, we don't have Andy and Subhashni with us today. And this is another Simple G project, very exciting. We're going to talk about margins of adaptation to human heat stress, local, national, and global socioeconomic responses. So in particular, we are looking into the effects of climate shocks on agricultural labor productivity and also what happens next. So next slide, please. As we all know from life recently, especially New York City last week, climate stressors have been intensifying and getting more severe. So to name a few, extreme temperatures come to mind, right? Cold, extreme heat, as well as sea level rise, increased or decreased precipitation. Lots of presentations in the forum were alongside the lines of various climate stressors. So in this project, we proposed that alongside these, we should have conversations about how all of this is going to affect our food systems, specifically changes in crop production and yields due to drought, reduced water availability, and other factors, you name it. So we do notice from the literature that the whole adaptation industry, policy or scholarship practitioners, they sort of focus on two levels. We do see farm level adaptation, so those would be on an individual farm level. So what would a regular farmer do? Maybe they're going to build a shed that's going to be air conditioned and then their cows are going to be very comfortable. Just a tiny example. Or we could look at system level adaptation. So those could be various policies that are introduced to mitigate, to adapt to changing climates, or maybe wide-scale automatization, things like that. We do argue that there's one link missing in all this literature. Oh, and before we start, okay, next slide, please. Okay, don't go. That's correct. The missing link is really labor, because labor really contributes to putting foods on our table. And we were in Boulder last summer. We were walking around. This is a picture from a local farmer's market. Great place, specializes in kombucha and sourdough, so very different from regular Midwestern farmer's market, but this did give us good context for our project. So we do want to look into how heat stressors influence farm labor, and then subsequently, what are the effects of changed labor availability on crop yields, prices, and other things. The effects are cascading and multi-scalar, and we only scratched the surface here. Before we dive into Simple G, we have the so-called isoquant curve on your right. I won't go into too much detail about it, but think of it this way. This is an equilibrium, a partial equilibrium model, and if you want to produce a certain amount of food, you either use more labor or more capital. One thing could swap the other to keep the equilibrium going. So we go ahead and model climatic shocks on the United States, a tremendously useful case for this study because agriculture is responsible for over $1 trillion of the US dollars in GDP. This is the second largest agricultural producer in the world, next to the European Union. And of course, the farm labor accounts for over 2.5 million jobs in the US, at least according to the official estimates. We all know that this, the informal employment in the sector is widely prevalent, so this figure is highly, pretty much underestimated. So this is our premise, those are our research questions, and to explain Simple G again a bit more, I'm gonna pass this to Dami.
Okay, so this project is based on the Simple G model. designed and created by the Purdue University team. So during the summer school, we looked at how we can use this model to just execute our own project. So what we majorly did was to come up with the code to account for the exogenous and the endogenous component of the model. Then we also went ahead to introduce 3 different climate shocks, which include heat stress, crop yield, which is in form of climate, and also water availability. And we ran 7 different scenarios, and using the GMPAC software, then we went ahead to extract the data for the heat stress, impact of heat stress on labor productivity. And you also used R for visualization, analysis, and interpretation. So these are the visualization for each of the shocks that we actually applied to the model, and she'll be talking more about Elaina will be talking more about the visualization. Yeah.
Can I use this one? Okay, so we ran several different scenarios with our climate shocks, 7 in total, and we ran these in different combinations to isolate their effects in the context of the others. And we also used a baseline model with only the socioeconomic variables. So we could take these in account. So this is things like population growth. And then we looked at the % change in our outcome looking ahead to the year 2050. And we ran the model for the continental US at both a regional level, so looking at the USDA food resource regions, as well as at a local level, so looking at the grid cell level. So we had about 70,000 grid cells covering the continental US. So with the simple G model, we were able to isolate the effect of heat. And so this first map here is showing the effect of heat stress on labor productivity. So on your right, you can see the regional effect of heat stress on labor productivity, and you can see the greatest decrease as a % change in the basin region, which is in the western United States. However, at the local level, we can see decreased hotspots in the southern and southeastern United States, so in places like Texas and Florida. So this really highlights the need to understand what's going on at the local level as well as at a regional aggregate level, where some of this local effects might be masked if you aggregate it. So on the next slide, we looked at this effect, or the heat stress effect on crop output. So this is sort of a spillover effect of the heat stress on labor productivity. So again, we see kind of the greatest % decrease in the southern and southeastern United States. Regionally, we see the greatest decrease in the Mississippi region. And we see the system sort of try and rebalance itself. So we see a decrease in Mississippi, but we actually see a relative % increase in the basin region. So we see a kind of, the model showing a kind of rebalancing to kind of try and increase crop output in one region where there's a decrease in another. So the effect is very based on the location. So on the final result, we see the cropland use change. So on the right again, you can see the regional increase in the fruitful rim, and this is sort of a substitution effect. So again, we saw a decrease in labor productivity in the southern and southeastern United States. And so we see a decrease in labor productivity there, but we see an increase in land use. So it's sort of an effort to increase the crop output by increasing land use, where you're seeing a decrease due to productivity, due to heat stress. And so the model really showed that we needed to understand what was going on locally and not just at an aggregated level, so we could understand the regional context as well. So there were some ethical concerns we were thinking about as a team as we were working through this local context and working at finer scales, as well as large secondary data sets, which I'll hand over to Sukanya to talk about.
Thank you, Elaina. Yeah, so for ethical considerations, we actually use the Dion checklist. It's a data science ethics checklist that was provided to us. And what we did for our project is we went through each of the subsections and we decided if it applied for our project or not. And what we saw is collection bias was an important one that really was applicable. So the data wasn't collected by us. So we don't necessarily know the process in which it was collected or how the progress of it occurred. And then also assumption of the uniformity. Gender, age, race was not necessarily considered as men, women, children of younger ages or older ages. They differ in how much heat capacity they can take. And then also unintended usage. We saw that there could be potential policy changes if labor migration was introduced. And so with that information, we actually compiled a list of other types of big ethical issues that might arise. And we created this word map, which emphasizes on some of the concepts that we kept seeing were really, really important, such as inherent bias and some of the multi-agricultural systems that were important components. And with that, I'd like to kind of go over what we did over summer school. So Simple G's, our group, we got a whole week. So Monday we began with conceptualizing the socioeconomic understanding and background of this model. And then we moved into using a mini model that was available on a web-based server. And we got to work with it and modify it and manipulate it to recognize the constraints of the model. And then we moved into developing a Google Colab, which has been talked about previously in the workshops and today, where we did packages, installation, and kind of began our visualization of our results. And then we picked our shock scenarios, and we used some of the deploying methods to apply it to the bigger, simple, full model. And then finally, we got to the last day and we compiled our checklist, began our visualization of our results, and then compiled our presentation. In total, we got 18 hours to work on our results, and this is what we came up with. And our future plans as a team is to make this into a publication and grow and see what else we can find, especially in those areas like Florida, Texas, and Louisiana, where we saw a lot of the impact. And with that, we'd like to say thank you to iGuide for this great, wonderful opportunity. And if you would like to see more maps and results, you can check out our QR code. Thank you.